Hello, I'm John Bruss, and I'm an acoustic engineer, and I've worked on transducers and hi-fi designs, acoustic designs, basically my whole life. So I'm bringing that knowledge here in headphones particularly. I want to talk about two different technologies in headphones. And the first is not just in headphones, it's used in all the loudspeaker systems that you see. And that is a dynamic driver. The dynamic driver uses a lightweight moving coil. Okay, the coil is attached to a diaphragm, a cone of some type that moves back and forth. On woofers, loudspeaker products, you've seen many of the round transducers. You see it on our Hero products. And the diaphragm moves back and forth. It's attached to a coil at the other side of that diaphragm. Both the diaphragm and the coil, particularly with the headphone drivers, has to be very light. So light that if you had the diaphragm and coil and put it in your hands with your eyes closed, you couldn't even tell it was in your hand. It's that light. And it has to be that light to be efficient, to give some acoustic output. In the design of those, you'd like to use a heavy coil. That would increase efficiency because the coil and the magnet work together for efficiency. But since it has to move, you have to keep it lightweight. Okay? So it has a rear magnet assembly, and it has what we call bandwidth operation, in that the flexibility of the diaphragm, when it moves back and forth, gives the low frequencies that you need. The more flexible, the more low frequencies it can reproduce. At the high frequencies, it has to do with the diameter of the transducer or the dynamic driver and the moving weight of it, producing the high frequencies. So there's a limit of how high it can go and how low it can go at the same time. Okay? And that's the bandwidth operation of all these types of transducers that are used in all the headphones and all the earphones that you listen to, except the ones that use balanced armature. The balanced armature concept is much more efficient because in this structure, the coil does not have to move. The coil is stationary, the magnet is stationary, and it moves this armature of steel back and forth, which drives the diaphragm. Okay? Since the coil doesn't move, the coil can be bulky and large, and that can increase the overall efficiency of the transducer. So these are used in applications where efficiency is really needed and very small size is needed. Our BA100 uses the ED, and I'll pass this around and you'll be able to look at it to get a feel for how large it is. These are used in hearing aids. All hearing aids in the marketplace use balanced armature transducers. So they're very efficient because they're large stationary coil, even though they can be very, very small. And you'll see some of them are extremely small. They have a stiff balanced steel armature. That armature has to be balanced between the magnets here. If it isn't balanced, the armature will just click to one magnet and you will have no transducer. So it must be very carefully assembled by the makers of these devices to balance the armature, thus the name balanced armature. It is not a bandwidth related transducer like this is. Okay, it has one resonance. It's in the vocal region. You're very careful when you design where you put that. When you seal your ear with this type of device, you get phenomenal bass. When you lose the air seal, even slightly, the bass disappears. So these require a total air seal between the product, the earphone using balanced armature, and your ear canal. And many tips are provided so that we can assure an air seal. And again, much different than this, no air seal, no bass. Okay? The treble response is tuned using a tuning tube and a damper assembly, and that's used in our BA100 and BA200. Next slide. The BA200 that we're coming out with is a two-way design. There are dual balanced armatures and even triple, and some have 4 and 5 balanced armatures. We decided to come out with a dual and use it as a woofer and a tweeter. So we have different size balanced armature devices. One is large and one is small. One is optimized to reproduce the low frequencies, and one is optimized for the treble frequencies. Okay? So they work together to give you the sound you need. The advantage, the two-way widens the bandwidth, so we can go deeper in the bass, we can go more extended in the treble, so we can get wider bandwidth because each is optimized for its frequency range. We have increased clarity also, simply because the treble driver doesn't have to reproduce the bass anymore. It's a challenge to reproduce the bass, and freeing that treble driver from having to do that, just like with a two-way or three-way loudspeaker system, greatly increases the clarity of the sound that you hear. However, if it's a two-way design, you need a crossover of some type. The crossover is usually in an inductor, capacitor, or some electrical component. And here's the two transducers, both of them running without crossover, or the tweeter running without crossover. And you can see this rise here is the distortion of the tweeter at low frequencies, because it wasn't designed to reproduce low frequencies. So we don't want that distortion. So with our crossover, you can see we can keep distortion very, very low by not feeding the low frequencies to the tweeter. That's accomplished with a crossover. That crossover is in the Y connection of the product. So you'll see the Y connection on BA200 is a larger assembly. It has a circuit board in it, okay? The crossover prevents the receivers interfering with each other by feeding just the bass to the low, just the highs to the treble, and it increases the clarity, as I said, so you can play cleaner music. It'll sound a lot cleaner, and if you play at high drive levels, it's really clean compared to the single transducer. Next slide. Leads me to another point. Since we had the crossover down here at the Y, where they come together, we also decided that balanced armatures, we noticed, have high inductance. Okay, inductance affects the impedance of the transducer. All the dynamic transducers, those round ones we talked about, have fairly uniform impedance. Bass frequencies, middles, and highs, very uniform. So they can be plugged into different products and doesn't make too much difference, no interaction with the amplifiers, very uniform impedance. But because of the high efficiency of balanced armature, the impedance varies with frequency. You can see that pink and blue curve up on the top, okay? That isn't a problem for stage performers who use these type of transducers. Alex Van Halen and others years ago came up with using these devices for on-stage performance. And I'm sure you've seen MTV and other live performances, even American Idol now. Everybody's got in-ear monitors and wireless transmitters and receivers on their back. So it's very, very common. They all use these type of transducers, but they have special amplifiers that don't care too much about the impedance. We're offering our products into a marketplace where we have different types of amplifiers, not those current amplifiers that the professional use. So this impedance variation here is a concern. So other very high-end balanced armature products that our competitors make will sound different when you plug them into different products because they have the varying impedance, okay? We decided to address that, and we now are pursuing a patent on an impedance stabilizing circuit that is also located on that circuit board at the Y connection. And it balances out that impedance difficulty in balanced armature. So that on all these types of products, we have a uniform sound. The same MP3 file sounds the same no matter what product you're listening to, okay? I also want to talk about the amplifier briefly because we have the SD800 here that has its amplifier and equalizer built into it. We found along the way as we were developing products that not only is impedance an issue, but the amplifier quality in some of these products is not that good. And that's because they certainly have a budget and priorities when they develop these products, and that little headphone amplifier barely made it on the screen, you might say. Very low priority. Same thing for the Dell, even worse with our Dell laptops. I like Dell a lot, but the headphone circuit is just barely there, just barely. These are a little bit better. But what you need for a good amplifier is you need to have swing the voltage. Okay, the signal, the audio signal, electrical, as it goes to the amplifier, must be able to swing and not hit the rails and get distorted because the amplifier was too narrow and restricted that signal swing. Likewise, you need a clear path that's very low in distortion so that when those peaks occurred, the amplifier has to deliver what we call current into the headphone, and a lot of these products, especially these, can't deliver the current, okay? So they start distorting a little bit, okay? We accept them. That's the marketplace. That's the products that are out there. But even the ST800 has a phenomenally better amplifier in it than this and this, okay? And if you have one and you listen with those products, you can try it sometime, switch it on, and just listen to program material that's nice and clean, and you'll be able to hear how much cleaner it is with the ST800 amplifier. And neutral tonality, bandwidth, low output impedance. A lot of these circuits have a capacitor in series. In fact, we know of at least one upgrade along the line with the iPod where they had to change the capacitor or get too many complaints because there was no bass response. People were buying phones that they knew had bass. They plug it in, and where's the bass? Disappeared. They'd plug it in another product. There's the bass. It's not here. And they had very small little chip capacitors in here, and they had to put larger capacitors because it was restricting the bass response, okay? So those things exist, and you may see in the future we may have other technologies to address that headphone amplifier marketplace. Next. And last, in closing, I'd like to talk briefly about isolation versus involvement. Many headphones are used in applications where you're in a fairly quiet environment and you want to listen to what's around you in the environment, whether it's your children sleeping in the other room and you want to see if anybody's crying or you hear a phone ring or whatever the issue is. You're involved in the environment and the music is along with it, okay? But increasingly so now, we have isolation interest in the marketplace where people want to be in their own world of hi-fi. So they either block the ear canal, with this happening to be at a modem version, where they block the ear canal and suppress the outside sound, or use an over-ear on-earphone that also suppresses the sound. The next step for the over-the-ear, since they aren't as effective as in-ear, is active noise cancellation, where you have circuitry and a microphone, and you can actually actively subtract the outside noise. So those products, as you're probably aware, are popular in the marketplace, and we may be addressing that too in our product lines. This one has an external set of electronics. Sometimes they put the electronics in the cup. One of the benefits here is there's no battery required for the noise suppression. Very robust, lightweight. Here, a little bit more complicated, and you have battery issues because it's an active noise cancellation. Okay? I think you'll see in the marketplace, this will continue, but I think there'll be a more and more emphasis on, if you want sound suppression, block your ear canals. For some people, that's kind of a new experience, but once you get into it a little bit, you go, hey, this is working just fine. Okay? So do you have any questions? If not, I'll hand it back to Trent.